Hey everybody, welcome to the Seneca OOP 244 Workshop 5 Lab Walkthrough for Fall 2024. In this workshop, we'll be looking at member operations and helper functions in classes in C++. So if we scroll down to where the lab starts, here we're making a class called account, and it's to replicate a bank account to have an account number and an account balance, and then we'll be overloading a bunch of the different operators like the plus, minus, and type conversion operators to perform different behaviors for a bank account. So let's actually scroll there to the top, and let's look at the files that they give us in lab. Let's start by creating a new project. We'll create a empty project. Next, we'll call this Seneca Workshop 5 Lab, create. So this workshop's a lot smaller. We only have our main and our account.h and .cpp. So let's right click and create those files. So new class, we're going to call this account. And now let's go inside the .h and copy the content that they give us. And then let's go into the CPP file. Let's copy what they have here into our CPP file. Okay, now let's right click here, add, we're going to do a new item, and we'll just call this our main.cpp. Let's go back and copy main. This is actually lowercase, let's rename that. And now we're going to copy what's in here and paste it. Let's go back over to the .h file and write some prototypes. So let's go back to the workshop, and let's scroll down to where the lab instructions are. So in our account class, we have two members. We have a account number and we have a account balance. The number is going to be an integer and the balance is going to be a double. So they already made the constructors for us. So all what we need to worry about are the different operators we have to implement. So let's start off by doing the type conversion operators. Let's start up inside the class here, and I'm going to put a comment to write type conversion operators. And we are going to create a Boolean, integer, and double operator. So let's start with the first one, the Boolean operator. To overload this operator, you have to write the keyword operator, and then the data type, so Boolean, bool, and then const, because we're not going to be changing anything inside of this function here. For this operator, it will return true if the account is valid, otherwise false. This operator cannot modify the account. So if we scroll up to see what a valid account is, we can see the instructions right here. An account is considered valid if the account number is a 5-digit integer with a 0 or positive balance. So let's go ahead and write that out. So let's hover over this. Let's create the function inside of this .cpp file. So we have two requirements. The account number needs to be 5 digits, and then our account balance needs to be equal or over 0. To start off, we could first check the account number. So we'll just say return, and we'll check the account number. So m_number. And if this is greater than or equal to 1,000, because this is the lowest, 10,000, because this is the lowest number that has 5 digits. Anything lower than that, it would be 9999, which is too low. So we want 5 digits, and we want to make sure that the account number is less than or equal to 5 nines, because anything bigger than this would now be 6 digits, which we don't want. And then lastly, we also need to check that our m_balance is greater than or equal to 0. So this is all what we need to do for the Boolean operator. Let's go back to the H file and let's look at the next thing we need to do. So next we will be doing the integer operator. So this will just return the account number. This operator cannot modify the account object. So let's do operator int const, because we won't be modifying it. Now let's hover over it and create the function. All right, so here we just want to return the account number. So we can return m_number, because m_number is what stores our account number. And then lastly, for our type conversions, we're going to do operator double const. Let's hover over it, click on it. And now for this function, we're just simply going to return the balance of our account. So this returns the balance value this operator cannot modify the account object. Let's just return that. Return m underscore balance. And this is done as well. Okay, so we did all of our type conversion operators. Now let's move on to the urinary member operator. So let's go back to our header, and I'm going to put another comment here. Urinary operator. The urinary operator is just this little the tilde here. So the operator returns true if the account is new or not set. So if the account number is 0. Otherwise, it will return false. This operator cannot modify the account object. So let's first write out the prototype. So we're going to write bool operator tilde brackets and then const. Now let's hover over this and let's create it inside of our .cpp file. Pretty much all what we need to do here is just check if our account number is equal to 0. So we'll just check m underscore number is equal to 0. So if it's equal to 0, it will return true. If it's not, it will return false. And this should satisfy this operator. Next, we have our assignment operators. So let's start off by writing the comment here. Assignment operators. So we're going to have two different assignment operators. So this first one says overload the assignment operator so a new account can be set to an integer. In doing so, you should set the account number of the account to the integer value. If the integer value is an invalid account number, the object should be set to an invalid state instead. If the account is not new, then this operator should not perform any action. In any case, a reference of the current object should be returned. So let's do that one first. We are going to overload the assignment operator, and we're going to return a reference to the current object, which is the account. So let's return an account reference, and we will overload the operator equal sign, which is the assignment operator. And then we're going to take in an integer, so we'll just say number, because this is going to be assigned to the account number. So here, let's say if our account number, m underscore number, is equal to 0, and then also if our number that's coming in is greater than or equal to 10,000, because we want to check if it's 5 digits, and if our number that's coming in is under than 99,999, then we can assign this to our current number. M underscore number is equal to number. And then we're going to write else. If it's not a valid number coming in, then we will do m underscore number is equal to -1, which is an invalid state. And then our balance will be set to 0. And then at the very end, we just want to return star this. So it's a reference to the current object. So this should satisfy this operator here. The next operator says overload the assignment operator so a new account can be set to another account object. This action should move the balance and the account number from one account to another. Therefore, unlike the usual assignment operator that affects the left operand only, this operator will affect both operands. The balance of the left account will be set to the balance of the right account, and then the balance of the right account will be sent to 0. The same will happen to the account number. If the left account operator is not new or the right account is not valid, no action should be taken. In any case, a reference of the current object account should be returned. So pretty much we're just going to be transferring the balance from one account to another. So for example, let's say these are both valid. We will be moving this balance and account number to this account. And then this will be empty. So let's go ahead and write the prototype for that. So it's going to be pretty much the same thing, but we're just going to now accept a reference to an account instead. Reference to an account, and we'll call it ACK for short for account. And now let's hover over this and let's create the function here. So we can start by writing if our m underscore number is equal to 0 and account. So by writing this, we're pretty much checking if our account number and our balance are valid. And the reason why this works is because we are overloading the Boolean operator. So it's actually going to be calling this function here when we call this. So if both of these are basically good to go, we will be transferring the account from one to another. So we can do m underscore number is equal to the account dot m underscore number. We will then be setting the m underscore balance is going to be equal to the account dot m underscore balance, and then we'll set the account dot m underscore number is going to be equal to 0, and then the same thing for the balance is also going to be equal to 0. And then at the very end, we will just return a reference to the current object. So this should affect the account because we're taking it in by reference, and whatever's on the left side of the operator because we're returning a reference to the current account. Now let's move on to the binary operators. So let's go back here and let's put another comment. Binary operators. So the first operator we're going to overload is the plus equals operator. So let's see what this says. Overload the plus equal operator to add a double value to an account. This should act like depositing money into an account. The value of the double should be added to the balance. If the account is in an invalid state or the double value is negative, no action should be taken. In any case, a reference of the current object account should be returned. So this is just going to act like we're depositing money into the account. So when we have an account here and we do plus equals a number, it will add that number to the current bank account balance. So let's start off by writing account reference because that's what we will be returning, and then operator, and we're going to overload the plus equals operator, and we're going to take in a double, and we'll call this amount. So this will be the amount we will be depositing. Let's create the function. All right, so here we just want to add the money to the account if it's a valid account and if the money is not negative, basically. So we'll start off by saying if star this. So this is basically saying if the current account is valid, and this only works because of our Boolean operator we're overloading here. So it will call this operator. So if our current account is valid and the amount that's coming in is greater than 0, so it's not negative or 0, then we will add that to our balance. So we'll do m underscore balance plus equals amount, and then at the very end we'll return a reference to the current object, which is star this. Now let's do the minus equal operation. So this is going to work the same thing, but it's going to act like withdrawing money from an account. If the account is in an invalid state, the double value is negative, or there is not enough money in the account, no action should be taken. So we can't withdraw more money than what's already in the account. And in any case, we're going to return a reference to the current object. So let's go ahead and write account reference operator minus equals. And again, we're going to be taking out a double as well. This will also be called amount. Now let's hover over it and create the function. So first, let's check if this account is valid by doing star this. And if our amount is greater than 0, and if m underscore balance is greater than or equal to the amount that's being withdrawn. So this prevents us from going into a negative account balance. So if that is true, we will just be subtracting the amount from our balance. So m underscore balance is minus equals amount, and then we're going to return this star, which is the reference to the current object. Now let's do the left shift operator. So to overload the left shift operator, we're going to move funds from the right account to the left account. So after the operation, the balance of the left account will be the sum of both of the accounts, and then the balance of the right account will be 0. That's because we're transferring the balance from the right account to the left account. One thing to note is that funds of an account should not be able to be moved to itself, so we'll block this operation, and then at the end we'll be returning the current object. So let's go and write this prototype here. We'll be turning an account reference here, and we're going to write operator left shift, and then we'll take in a reference to an account here, and we'll call this other, so we know it's the other account. So let's hover over this, clean up the function here. So first, let's make sure both accounts are valid. We'll do this by saying star this, which we'll call that Boolean operator, and other, which we'll also call the Boolean operator for the other account. And then we also want to make sure that the account is not the current account. So we'll just say if this is not equal to other. So this ensures that they are both different accounts. And then we can do m underscore balance, and we're going to add the balance from the other account. And then we're going to set the other dot m underscore balance to 0, because that means we're transferring the entire balance to the current account. And when we're done, we'll just return a reference to the current account. Next, we're going to do the right shift operator. Put the same thing here, account, reference, operator, right shift, and then a reference to an account. And this will be called other as well. So for this operator, we will be moving funds from the left account to the right account. After this operation, the balance of the right account will be the sum of both of the accounts, so of the current account and the other account, and then the left account will be drained down to 0. Again, funds can be moved to itself, and this operation won't do anything if that's the case, and then at the very end, we'll return a reference to the current object. So let's go and create the function here. So first off, let's make sure that both accounts are valid and that it's not the same account. So we'll say if star this and if other. And again, we're going to say if this is not equal to a reference of other. So this means that they're both valid and it's not the same account, ensuring that they're both different. If this is the case, then we'll add our balance to the other account. So other dot m underscore balance plus equals our current balance. And then we're going to set our current balance to 0 because that means we just transferred our entire balance over to the other account. At the end, regardless of what happens, we will return a reference of the current object. So now that is all what we need to do for the class members. Now we need to create two helper friend functions. So let's go back inside of our .h file and to write the prototype for a friend function. So let's start off by first writing helper friend operators. We need to use the keyword friend. So for this operator, we'll be returning a double, and the operator is going to be the plus operator, and we'll be taking in two parameters. So we're going to have the left-hand side and the right-hand side of our plus operator. Both of them are going to be const account references, and this will be LHS to stand for left-hand side, and then we'll also make a const account reference, and we'll call this RHS, which stands for right-hand side. So let's go and make the function over here, and let's read what we actually need to do. Create a binary standalone helper plus operator that accepts a constant account reference at the left and another constant account reference at the right, and returns a double value. The double value should be the sum of the balances of the two accounts. If any of the two accounts is invalid, then 0 is returned. So pretty straightforward. We're just going to add the two account balances. If one of them are invalid, we'll return 0. So a simple way we can write this is just say if left-hand side is valid and if right-hand side is valid, we will simply return left-hand side dot m underscore balance plus right-hand side dot m underscore balance. And then down here, we can just say return 0. So if both accounts are valid, we'll return the sum. If one of them are not valid, we'll just return 0. And that satisfies this condition. Lastly, let's create the plus equals operator. Create a binary standalone helper plus equals operator that accepts a double reference at left and a constant account reference at right and returns a double value. The value of the balance of the right should be added to the left operator, which is the double reference. Then the value of the double reference is returned. So what this means is we're going to get a number, we're going to get an account, and then we're going to add the account to whatever this number is, and then returning that full sum. So let's go back to our header file and let's write out the prototype for it. For this function, we're going to have to write friend again because it's a standalone helper, and we are going to return a double reference. And the operator is going to be a plus equal sign. And then we're going to write our first parameter, which is a reference to a double. And we'll call this the left-hand side again. And then on the right side, we're going to take a constant reference to an account. And we'll call this right-hand side as well. Now let's hover over it and write the actual function, clean it up. So all what we need to do here is just check if our account, which is the right-hand side, so check if the account is valid. If it is, add it to the left-hand side and then return that variable. We'll say if our right-hand side is valid, then let's just add it to the left-hand side. So left-hand side plus equals our right-hand side dot m underscore balance. So this will add our balance to that double variable. And at the very end, we can just return our left-hand side because it's going to be taking in a double reference, and that's what our left-hand side is. So at this point, we should be done writing out all the code. Let's actually run and compile it, and let's make sure it matches the output we're expecting. So let's go down here and click Correct Output. So now let's click into Visual Studio, press Ctrl F5 to compile and run it. It ran. Let's see if it's correct. So let's close this a little bit. And now let's scroll to the top. Now let's compare all of the lines. So we're starting off by account 1s and 1.1, 2s, 2.2. So this looks like it's right. Account 3 should be bad. This is bad. Row 4 should be all 4s. That looks correct. 5 is all 5s and 5.5, which looks correct. Then we have bad account on 6, bad account. Then we have 7s on 7, and then the last 3 are all new, and the last 3 are all new. So that looks like it worked. Now let's check the plus equals operator. We have account 111, 161.13, 161.13. So the plus equals operator seems like it works. Next, we'll look at the minus equals operator, which looks like it also works. Account 2, and then 122.2, okay. Next, we got the minus equals operator again. So we're going to be doing 444.4, so the account did not change. Next, we're going to try depositing and withdrawing negative amounts. So also it did not change, so that looks correct as well. That also looks correct. The next one, cool. Now let's having these two accounts. So 161.13, 122.21. So these both look correct. And now we have 0.28, 0.28. So these all look correct. So we move the funds back now. We move the funds back. That also looks correct. And then at the end, we have count 1111, 283.34. So that also seems like it's correct. And then let's see what we have here. 1,333.32. That looks correct. Okay, so these all look correct. And then account 8, this is equal to 0. Okay, it's still equal to 0, but now it's not new anymore. It has an account number, so that seems like it's correct. Next, we're checking if we move the account back and forth. So 8s and new. Here we have new and 8s. So that seems like it's also correct. And then down here for displaying all accounts, we have 283, 0, bad account, 4,500, account, 700, new account, account that has 8s, another new account. And then let's scroll down a little bit more. We have all 7s, all 7s. That seems correct. Bad account and 7s, bad account 7s. Same thing again, bad account 7s, bad account 7s. That seems like it's correct. And then we have 7s and a new account 7. And then at the very bottom, we have displaying the raw values here. So we have 1s, 2s, -1, 1s, 2, -1s, 4s, 5s, -1, 0, 7s, 8s, 0. So that seems like it all matches. And then for the balances, 283, 283, 0, 0, so 0, 0, and then 4, 4, and then 5, 4, 4, 5, 2 zeros, 2 zeros. Then we have 7 and then 2 zeros, 7 and 2 zeros. We have total 2 new accounts, 2 invalid accounts, and 2 new accounts, 2 invalid accounts. Yeah, seems like it works. Let's just run it in the command line to make sure we have nothing crazy happening. Let's close this. Let's right click on this, and then let's go down to open in terminal. By the way, I had to switch this to the developer command prompt. I had PowerShell open and it wasn't working before. So just switch it over if it's not like this already, or just type this in your matrix. So first I'll do WSL, and you probably won't need to do this. I just need to open up my Docker instance here. Now I'll do sudo apt update to make sure we're up to date. While this runs, let's go find the command back inside the lab here. So if we scroll down, it should tell us what the command is, or scroll up. Here it is. All right, so let's clear this out. Let's do g++ -w wall -std equals c++11 -g -o. We'll call it ws for workshop, and then our 2 files. So we have main.cpp, and then we also have account.cpp. So again, we only need our source files. So this should compile. We're not in the right directory, it says. ls. Oh, we just need to go inside of the workshop there. So cd Seneca labs. Okay, so now we should be in the right workshop. So if I press up to the command again, it should compile now. Cool. Let's run it. So /ws, make sure it still runs. Looks like it's all correct. I'm just going to compare the last line here. So we should end off with 28, 0, 0, 4, 5, 0, 0, 7, 0, 0. Okay, so it looks like it still works. Now let's run it with Valgrind and make sure that we have no memory leaks, but we're not managing memory here, so there's no reason why we would have memory leaks. Let's just do it just to be sure. So copy, I'm going to right click to paste it in, and then I'm going to do /ws to run the workshop, and now when I press enter, we should have no memory leaks. Awesome. Looks like there are no memory leaks, and we're in the clear. So hopefully this helps you submit and gets you ready for your midterms coming up. Good luck, and please let me know in the comments if you guys have any questions or need any more personalized or tailored help towards you. If you guys are falling behind, there should be no reason why you are. Please reach out, and I'll be more than happy to help you guys out and build out a path for you guys to follow.